the history of calculus first before we start the chapter 2. Okay. History as well as the science was born long ago, but modern science and calculus was started in the period of year 1500 to 1630. This is called the stage 1. Yeah. So now, the knowledge of science is all of the speculation starts to become a science. Ptolemy of Alexandria, actually, he wrote Almagest, the summary of astronomy, the book, in 2nd century AD. But in here, there is no experiment or logical thought. But he wrote that the Earth is the center of the universe. Okay. But so we may think this is the starting point of the science and calculus. Copernicus in 15th, 16th century raised the problem on motion of the moon, and he published the revolutionary buzz. Here, he mentioned the sun-centered universe with the moon orbiting around the earth. Okay. Catholic Church banned this book until 1835. Okay. So, even though he really write the scientific fact, the world was not ready to accept it. Tycho Brahe in 16th century, he was a genius observer. He wrote a lot of record on trajectory of the moon and planet. He compiled a huge amount of data. Okay. Later, Kepler used those data to make the history. One interesting thing is, as you see here, there is a scar on his nose. He lost his nose when he was a student in a duel in 1566. You know what is the duel? 칼싸움. 둘이서 1대1 대결하고선 할 때, 학생 때 코를 잊어버린 사람이에요. Anyway, Johannes Kepler in 16th and 17th century, he is a genius in analyzing data. He became a Brahe's assistant in 1599. And he believed the word of Copernicus. And he started to find the model of sun-centered universe. And after his experience with Brahe, and he discovered quantitative laws based on his data. Then he published the books, several books, including Copernican astronomy in these years. In 3 years, he published 3 books. And what Kepler said was abbreviated as 3 laws. His first law, which was discovered in 1605, says the orbit of each planet is an ellipse, with the sun at one of the 2 foci. So sun is here in this universe. That's his Kepler's first law. Kepler's second law, which was made in 1602, a line joining the sun to an orbiting planet sweeps out equal area in equal time, as you see in this graph. You see, as this area and this area same, and the time that takes from here to here is same as from here to here. That's what Kepler's second law said. His third law, which was made in 1618, says the square of a planet's orbit period is proportional to cube of its distance to the sun. Those really made open the eyes of people in those era. Okay, now, the stage 2, from 1630 to 1680. Here, the people started to believe that science is written in the language of mathematics, because all those earlier observations were formulated and written in mathematics. So, Galileo Galilei, in 15th and 16th century, he is considered as the first real scientist, because he starts thinking in these steps. First, state a hypothesis and devise an experiment to test it and carry out the experiment. After that experiment, he decides to accept or reject the hypothesis. Okay. He is the one who keeps this law. But he always worried about the money and also worked on inventions to get rich. So he tried to invent thermometer or calculators and many others. Okay, but he also interested in movement of objects, so he constructed the improved telescope in 1609, and he published the books, including the first modern scientific textbook in 1638. This is the disclosure and mathematical demonstration concerning two new science. Okay. After that, René Descartes, in 15th and 16th and 17th century, and he invented Cartesian coordinate. Cartesian. This Cartesian comes from this cart. So this Cartesian coordinate is Descartes' invention. This cart. He introduced the letters X, Y, Z to denote unknown quantities in mathematical problems, like you use now, okay, in equations. He also published Principia Philosophiae in 1644. Okay. Third stage is around 1680. Here, people start to speak with the language of mathematics. In here, the way of study, the way of do science followed this step. State the hypothesis and devise an experiment to test it and carry out the experiment. Then we decide to accept or reject the hypothesis. In 1673, Huygens, outward force on object in circular orbit of radius r is proportional to r square. Okay, so science has been developed. 1674, Robert Hooke found the Newton's first law of motion, radar. What Hooke found was called as the first Newton's law of motion in radar. Okay. In 1684, Halley and Wren and Hooke made the hypothesis. The sun attracted planet at distance r with a force proportional to r square. Is it possible to derive the observed motion of the planet from this inverse square law? Somewhat later, Halley visited Isaac Newton, and the record was made by Newton's friend de Moivre, and in his note, it's written like this. Dr. Halley came to visit Isaac Newton in Cambridge, and Halley asked him for the calculation without, for what? For these problems. This problem. Regarding the planet, the motion of planet, and solving it by mathematical language. Isaac Newton looked among his papers but could not find it. But he promised him to renew it and then send it him. That's the start. Newton. These are, Newton and Leibniz are the parents of calculus. Yeah. That's the start of the real calculus. Isaac Newton developed mechanics, calculus, and theory of light even before his age 30, like your ages. In 1687, he published Philosophia Mathematica. Okay. He published many other books, but he's a giant. Gottfried Leibniz invented calculus independently of Newton. Okay. Now the notations of calculus that you are using is what Leibniz invented. That's Leibniz's notation in calculus. It is in fact what we use today. Okay. And then Newton and his successors established the science, quantitative science, all quantitative science actually, including physics, biology, economics, etc. That makes England stronger. Okay, now science is no longer descriptive. After that, after those work, now science is no longer speculation or descriptive, but aimed to finding out the usually mathematical law underlying the observed phenomena. Galileo's principle defined the procedure for finding the underlying laws. Then now, after Newton and Leibniz, take this form. State a hypothesis, first step. Second step, devise an experiment to test it. Third step, says calculate the predicted outcome of the experiment from the hypothesis. Fourth step tells carry out the experiment. Last step is the step to decide whether to accept or reject the hypothesis. When there are several distinct hypotheses, choose the simplest hypothesis. Okay. Those are the very history of the birth of calculus. I may mention that here. The first step, how to find a hypothesis. How they have found the hypothesis. What do you think? So, now the most important thing is to find this kind of hypothesis or conjecture. In order to get, you need to be exposed to more diverse situations, and also you need to interactively practice to have a new view of a situation. And also this computational tools has been developed recently And now our students are quite ready to do simulate and also to do compute, to make conjectures and also solve those conjectures. So I hope our new generation will make a great contribution in the 21st century science. Okay. Next, we're going to start the chapter 2.